Hey guys, today we're going to start 9A, part 1. And in Target 9A, we're looking at the properties of exponential and logarithmic functions. So, if you want to look at the graph, so the first thing I'm going to do is I'm going to use my calculator to graph y equals e to the x. So I'm going to open a new document. And I'm going to add a graph. So I'm going to graph y equals e to the x. So control, where e is here. Oops, not control, sorry. Just put e to the x, and I have to type in x. So here's our function. Just a few key things I can see already. It passes through my y-axis at 0, 1. I'm going to put a point there. If you look closely, it never actually crosses the x-axis. It actually has just going along it there, and then it goes up. So we're going to look at some of these key features. If I look at this graph, again, it never actually crosses that x-intercept. I'm going to change this quickly so I don't have to keep flipping back and forth. Let's try. Yeah, that'll be better. I can see both of them. It never actually crosses the x-axis. So what's my x-intercept? Well, if it never crosses the x-intercept, then it has no x-intercept. There is none. Again, for the y-intercept, the easiest way, if it's not something you can easily see, is menu trace and graph trace, and usually it puts you right onto that y-intercept. So menu trace. Okay. So my y-intercept, it is a point, so that point is 0, 1. The end behavior, it gives us two spaces for end behavior. We have the limit as x approaches negative infinity of f of x. Right? Well, as I go towards the negative side, right, it's getting closer and closer to that x-axis, but never crossing it. And the y value of the x-axis is 0. On the other side, the limit as x approaches infinity of f of x equals, right, it's going up and up and up, it equals infinity, right, on this side over here. Domain, right, as I go from left to right, there's no stopping point. So my domain is negative infinity to infinity. It has no vertical asymptote. It has no holes or anything like that. So it's just negative infinity to infinity. My range, well, it does have a horizontal asymptote. Like I said, it never crosses over the x-intercept. So 0 to infinity, right? It starts around 0 and goes up. Asymptotes, again, we know it has this horizontal asymptote. We said it was 0, but what is 0? Well, for this one, right, horizontal is y equals. So y equals 0. And then is this function increasing or decreasing? Right, well, if I start left and go right, my pencil would go up when I draw this, so it's increasing over its whole domain, negative infinity to infinity, and it is never decreasing. So that is our function, right, our properties of that function. All right, let's look at our next function. We have the natural log of x. Okay. Well, I'm just going to delete this function. And you control natural log of x. Okay, so, if I'm graphing this function, right now it's never passing this line, our y-axis. So I'm going to look for my x-intercept. I'm going to start there before I finish graphing, so I kind of know what my graph looks like. Remember, x-intercepts are zeros to the left, to the right. My 0 is at 1, 0. And we'll go up, and then it keeps going up and up and up that way. Now, looking at some of our properties of this graph, we have for our x-intercept. right? We just found it. It's 1, 0 again. That's menu 6, 1. Now for this one, we can see, just like our last one never crossed the x-axis, this one it's actually getting closer and closer to the y-axis. I can go to menu trace and graph trace, right? And it does say 0 is undefined. It's never actually touching that y-axis. So this one has no y-intercept, so none. The end behavior, we've talked about the end behavior a little bit with logarithm. It's a little bit funky. The limit as x approaches negative infinity of f of x. Remember, it's just like Mean Girls. It does not exist because it doesn't have a left side of the graph. My graph's stuck. And then the limit as x approaches infinity of f of x equals, right, well, it is going to go, I know it's going up slower, but it is going up forever. It is infinity. Alright, for the domain, again, this one's a little bit different as well. It doesn't go over here. If I trace this, right, there's nothing on this side of my graph. So this one starts at 0, but it will continue on forever, right? As I move right, I will have stuff. As I go right, it will have values. The range, right, now the range, right, it goes down forever, right? There's down at the stopping point going down or up. So my range is negative infinity to infinity. My asymptote, right? There is a vertical asymptote, right? It never crosses that y-axis. That y-axis is vertical. So vertical lines are x equals, and it's x equals 0 there. And is this graph increasing or decreasing? As I use my pencil, it would also be going up. So it's increasing on its whole domain, negative infinity to infinity, and it is never decreasing. All right, so let's look at the properties we just found of these two graphs. If you look, our first graph had no x-intercept, but the y-intercept was 0, 1. Our other graph had an x-intercept of 1, 0, and our y-intercept had none. You should see that these are kind of flip-flopped. Your x and your y values are just flip-flopped. For x-intercept and y-intercept, those match. Your y-intercept and your x-intercept, again, in those intercepts, your x and y are just flip-flops. Oops, sorry. The limit of the end behavior, it's harder to see how it flip-flops, but it does as well, because the whole graph flip-flops. Same thing with domain and range. My x and my y flip-flops, because remember, these are inverse functions. So my domain, which is x values, is equal to my range, which is y values. My domain of x values is equal to the range, which is y values. Asymptote, x and y flip. And then, sorry, this increasing should be 0. It should be on my whole domain, which is 0 to infinity. And again, they kind of flip-flop. This is my x, this is my x here. So then they flip-flop. Okay, so you can kind of see how these functions are related. Their properties are very closely related. All right, let's look at the next page. 2 more graphs we are going to do. So y equals a little bit more complicated other graph. Y equals 2 e to the x plus 1 minus 4. I'm going to pull this back over here. So here, I'm going to delete this function. I'm now going to do 2 times e to the x plus 1, and I have to come out of my exponent and do plus 4. Minus plus 4. That's why it looks weird. Sorry, guys. It should be minus 4. There. My graph actually looks like looking at that graph. Close enough. Alright, so let's figure out what my x-intercept is for this graph. So the x-intercept, again, I'm going to go menu, analyze graph, 0, to the left, to the right, it's negative 0.307. Again, your intercepts are points, so negative 0.307, 0. Finding my y-intercept, I'm going to go menu, 5, which is trace, graph trace. It should give me that exact point, 1.44. For my end behavior, the limit as x approaches negative infinity of f of x. Well, what is my y value getting closer and closer to, right? I'm at negative 3.9, negative 4.2. I'm sorry. I was looking at the x value. Right, as you can see, as you go down, right, looking at these, I'm looking at this point here, looking at my y value. It is getting closer and closer and closer to, and eventually just says negative 4. Okay? So you can trace, or you can look at it, or you kind of start looking at what is being subtracted here. Right? It's -4, it's going to move forward in some way that does affect your end behavior. For the other side, the limit as x approaches infinity of f of x equals, right? The other side is going to go up for x is approaching infinity. Domain for exponential functions, there's nothing that stops the domain, negative infinity to infinity. For range, well, my y value that approaches negative infinity is approaching negative 4. So it's never going to get past negative 4. It is going up forever, so it's going to approach infinity. My asymptote, well, again, my end behavior, my range, all of these things are approaching negative 4 in my y value. So y equals negative 4 is my asymptote. The graph is never going to get below that line. And then it's just increasing or decreasing. It is increasing the whole time. It is never decreasing. All right, let's look at our second graph. We have y equals the natural log of x plus 4 over 2 minus 1. Y equals the natural log of x plus 4 over 2 over 2 over 2. So here my graph looks something like this. We have both an x and a y-axis. So let's figure out my properties. My x-intercept. You can see it's already actually given to you there. It says 1.440. Sometimes when you don't change to a new graph, it'll keep the features on the graph. It's kind of nice. Not always, though. Okay. At 1.440. I want to find my y-intercept, so I'm going to use trace, graph trace, 0, 0, point negative 307. 0. End behavior, the limit as x approaches negative infinity of f of x. Now, this graph has shifted over even more, but if you look, it's still not going to get past a certain point. Okay? Not moving all the way over. My x values are cut off. So, this one is also does not exist. And again, you can look at that with the trace as well. Right? It starts being undefined. So then for infinity, the limit as x approaches infinity of f of x, again, these graphs do go up forever, it does equal infinity. My domain, now where is it going to stop? I'm at negative 3.6, I'm at negative 3.9, negative 4.2, it stops. So where is it actually starting? It's actually starting at negative 4. Again, probably going to be one of the numbers in your function. Negative 4, and it will go on forever. For logarithmic, right? They have no restrictions on the range. Asymptotes, again, we see it gets stopped at -4, right? So my asymptote is going to be x, right? Since the domain gets stopped, x equals -4. And then is this function increasing or decreasing? This is also increasing on the whole domain, never decreasing. Again, we can look at all of these properties together. These two were also inverse functions. I changed them the same way. And you can see the x and the y-intercept are just flip-flops. And both of them. Domain and the range are just flip-flops. The asymptotes are the same, just flip-flops. Right? So when you do those inverse functions, all your x and y values are just switched. Alright, that is it for tonight. I will see you guys tomorrow.